Greetings aspirants, welcome to CC Concepts of the subject Science and Technology, and today we are going to talk about the types of orbits. First of all, why are we even talking about the orbits? We are talking about the type of orbits in the context of ISRO launching many satellites into different types of orbits. In this context, you have to know what are different kinds of orbits and on what basis they are classified, and we'll get into the details of it. Before that, why did this concept even come up? Consider two masses in space, m1 and m2, and there is some gravitational force if they are at some distance r. But when these masses come close enough with enough momentum, then they start orbiting around each other. Hence, we can say that orbit is a curved path of one object around the other. But take this case in case of a solar system. In our solar system, the sun is of the highest mass, so it pulls up all the planets with gravity. In this way, Earth revolves around the sun, and the same way the natural satellite of the Earth, which is the moon, that revolves around the Earth. Right. Now, if we come into the classification of the orbits are mainly classified based on four types. The first category being the shape, second category being the height, third category being the revolution, and fourth category being the inclination. Now, if we talk about the shape, the orbits can be either elliptical or circular, right? And on the second classification based on the height, we have low Earth orbit, mid Earth orbit, and high Earth orbit. And the third classification based on the revolution, we have geosynchronous and sun synchronous. And the fourth classification, inclination, we have equatorial, polar, and inclined orbits. Now, if we talk about the orbits based on the shape, there are basically two types, as I told you. Circular orbit, where the Earth or the object with a higher mass is at the center of the circle. In the second case, where the elliptical orbit, we have the mass at one of the foci or the focus of the ellipse. One of the foci or at the focus of the ellipse. And we can see other kind of elliptical orbit, which is highly elliptical orbit. We can observe these kind of orbits in geostationary orbits, geostationary transfer orbit, which we'll talk about further. Now, coming to the orbits based on height, we have low Earth orbit, which are the orbits at the height of 800 kilometers to 2000 kilometers. Secondly, the medium Earth orbit or the mid Earth orbit, which is at the height of all the orbits between the height of 2000 and 35,780 kilometers comes under the mid Earth orbits. And lastly, the high Earth orbit, which is greater than or equal to the height of 35,786 kilometers. Lastly, we have the high Earth orbits, where we observe the satellites or the orbits at the height greater than or equal to 35,786 kilometers. The examples of high Earth orbits are geostationary and geosynchronous orbits, which you might be seeing in the news frequently. This is a pictorial depiction of all the orbits which we talked about. I'll be talking about all these orbits in detail now. Firstly, before we move on to the detailed discussion, this is the pictorial representation, and for your comparison, this is the lunar orbit. Lunar orbit, the orbit in which the moon revolves around the Earth. And these are the orbits, as I told you. Low Earth orbit at the height of 180 to 2000 kilometers, mid Earth orbit at the height of 2000 to 35,780 kilometers, and high Earth orbits and geosynchronous orbits at the height greater than or equal to 35,786 kilometers, which are the highest. Now, talking about the low Earth orbit. In low Earth orbit, the main purpose or the main significance of these orbits are the satellites are sent into orbits, these low Earth orbits, for mainly communication and remote sensing purposes. You might be having a doubt, like how the communication satellites are sent for such a low height orbit, and we are getting this communication. The communication satellites put in low Earth orbits are going to have a series of satellites or going to have a network of satellites, which are going to be at like different places, and these are going to help us with the communication. And the International Space Station where the research happens in the space is at this orbit, because it is very easy for the astronauts to travel back and forth from space to Earth and from Earth to space. This is the purpose or the significance of the low Earth orbits. Now, talking about the mid Earth orbits, the main advantage we have at the mid Earth orbits is that the satellites are going to have multiple paths for traveling or rotating around the Earth. And mainly the satellites related to the navigation systems. Navigation systems are going to be there in the mid-earth orbits, and the global positioning system, or the GPS, which is the navigation system of the United States of America, is positioned in this particular orbits, and this is the pictorial depiction of the GPS satellites in space. Now, if we talk about the high Earth orbits, the main orbits we can say at this height are the geostationary and geosynchronous orbits, which I mentioned earlier also, and the satellites put in these orbits are used for telecommunication and Earth observation. The main purpose of these satellites being put in the high Earth orbits is that once the satellites are in the high Earth orbits, the satellites are going to cover a vast distance. Like the coverage of these satellites is going to be more compared to the satellites which are in the lower orbits. In this way, these satellites can be used for the Earth observation. Now we have seen the low Earth orbit, mid Earth orbit and high Earth orbits. Coming to the based on revolution, we have two types of orbits which are geosynchronous. The geosynchronous orbits are nothing but the orbits or the rotation of the satellites on these orbits is going to be in sync with the rotation of the Earth. In simple words, you can say that the rotation or the revolution of the satellite around the Earth, the angle of inclination between the Earth and the satellite, it's going to be the same at all the times. It's going to be the same at all the times. But if we talk about the sun synchronous orbit, in simple words to make you understand, we can say that the orbit is going to, the satellites in these orbit are going to be rotated in such a way that the inclination between that satellite orbit and also the sun is going to be the same. We'll talk about this and I'll show you a picture which may help you understand better. This is the pictorial depiction of the geosynchronous orbit. So if the satellite is here, we can say that the time taken by the satellite to revolve around the Earth is going to be the same as the time taken by the Earth to rotate around itself. So the revolution time of this satellite is going to be 23 hours 56 minutes approximately, which is the exact same time the Earth takes to rotate around itself. In this way, we are calling it geosynchronous. Now, there is one more orbit called the geostationary orbit, and you might be getting confused because these words are mostly used interchangeably in many newspapers or many websites. But there is a very fine difference. Between these two orbits. You have to understand that the geostationary orbits need not be parallel or need not be on the same line with the equator of the Earth. But whereas the geostationary orbits are always parallel to the equator, of the Earth. This is the main difference between the geostationary and the geosynchronous orbits. So as I told you, the geostationary orbits, the orbit is always inclined to the equator, whereas the geosynchronous orbit may not be inclined to the equator. And as I told you, considering this is the sun synchronous orbit. So the satellite from here is going to complete its revolution like this, and it's going to reach here. And the second revolution, the satellite is going to reach here. You can say that the solar mean time, whenever the point crosses a particular point on the Earth, it's going to be the same. In this way, this is the kind of revolution the satellite is going to have around the Earth in case of a sun synchronous orbit. So as I told you earlier, if you look at the inclination between this orbit and sun, it's always the same. This inclination is always going to be the same, and it's not going to change in case of the sun synchronous orbit. And lastly, the last categorization based on the inclination, we are going to have equatorial orbit, which are going to be parallel to the equator, which are going to be at the same in the same line of the equator. Then you have the polar orbit, which is in line with the poles, of the Earth. And then we have inclined orbit at any inclination irrespective of either equator or either poles. Basically they are inclined to both orbits. So these are the orbits based on the inclination. And lastly, we have something called geostationary transfer orbit. So in simple words, you can say that this geostationary transfer orbit is like an intermediate step, for sending a satellite into a particular orbit, mostly geostationary or geosynchronous. The main purpose is that sending the satellite directly into that orbit is not that efficient, but we are going to send satellites in such a way that we are going to launch it like this, so that it is going to take its geostationary transfer orbit, and from this orbit it gets transferred into the main orbit. Based on this, or based on, like, for this purpose or this for meaning, we are going to get this, we got this name geostationary transfer orbit, right? For this I am going to show you a short example. When we sent the Chandrayaan-3 to the Earth, to the, around the moon, this is the geostationary transfer orbit it took, and from here it got transferred, and here to get into the last orbit, it took the geostationary transfer orbit path. I think you have understood what are the types of orbits. In this video we have understood what is an orbit, the concept of orbiting of one mass around the Earth and the solar system, and then later we categorize the orbits based on different different factors. Then we discussed each type, and we also saw the significance of the satellites in each orbits. We'll be back again with the next video. Thank you.